3, 2, 1, let's go! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're going to be looking at the floor method. Now the object of the floor method, which is part of the math library, is to return the largest integer that is less than or equal to the number that you provide. Sounds simple? Well, of course it is. Let's see how it works. Now let's take a look at how Math.floor works. I have two examples here. This is how Math.floor looks like inside code, and it takes one argument, and that one argument being the number in which you wish to floor. Again, what is floor? Well, floor is finding the largest integer that is less than or equal to the number that you provide. So for example, my first number I'm going to look at here is my cat weight, which is 3.2. When I Math.floor it, I should expect the approximate cat weight variable to become 3, because 3 is the largest integer that is less than or equal to the number in question. Consequently, with the dog, I have a dog weight of 22.7. So when I do a Math.floor on the 22.7, I should expect approximate dog weight to come out to be 22. So again, it's not like rounding the number. So if we were rounding the number, 22.7 would come up to 23. It is taking the largest integer that is less than or equal to the number. So again, approximate cat weight should come out to be 3 because I've done the Math.floor here. And the approximate dog weight should come out to be 22 because I've done the Math.floor here. Let's take a quick look at that. Let's flip over to Node and let's type in node floor. Yep, sure enough, my cat weighs about 3 kilograms and my dog weighs 22 kilograms. So this shows this is not a rounding function. This is a function for getting that largest integer that is less than the number you supply to it. So what happens with negative numbers? Hey, it's the exact same thing. Let's throw some negative numbers into here. Just happen to have some code. Let's just pop it at the very end here. I have a temperature of negative 1.6 and I'm going to floor that one, and I have a temperature of negative 5.1 and I'm going to floor that. So what's going to happen? Well, again, remember, negative 1.6 is actually going to come out to be negative 2. Why? Because negative 2 is the largest integer that is less than negative 1.6. It's not going to round itself up to negative 1. It's going to go down to negative 2. Consequently, negative 5.1, the largest integer, is going to be negative 6, because negative 6 is less than negative 5. You want to make sure? Of course you do. Let's go back over to Node, and let's clear off the screen, and let's type in node floor again. And yep, that's exactly what happened. Now my cat still is 3, my dog is still 22, but the temperature for day 1 was negative 2 Celsius, while the temperature for day 2 was negative 6 Celsius. So that shows you basically how Math.floor works, and that's really all it is. Like I've said about 600 or 700 times already, it is the largest integer that is less than or equal to. So let's take a look at some of the strange things that could happen if you don't pass a number to the Math.floor. We'll do that next. So now let's find out what happens when you don't pass a number to Math.floor. Let's take a look at strings first. I have a string here that looks like a number. I have a string here that doesn't look like a number. And I have a string here that doesn't look like a number, but it begins with some numbers. Well, so what's going to happen? Well, first of all, let's think about this for a minute. JavaScript does things something that's called type coercion, and that basically says that if I have a string of 1.2, it may sit there and say, you know, for certain operations, I'm going to kind of interpret this as the number 1.2. So if that's the case, I would actually expect this to work correctly and print out number 1, because it's going to coerce this string here of 1.2 to a number of 1.2, and then it's going to perform the operation. Here, I would expect it to return not a number because the string is not a number. So you can't do a Math.floor on a not a number. This one, I would actually expect it to return a 1. Now, why is that? And that's because I begin it with a 1.2. Now, if you remember from our parse int episode that we did a couple of weeks ago, if you have a string there that begins with a number, it will parse up all the numbers up to the first non-numeric character and then use that number. So I would expect Math.floor to do the same thing, right? Right? Of course, you know it's not because I kind of gave it away there. But let's take a look at Node and see what happens. Let's flip back over to Node. Let's type in node strange. So number 1 came out correct. The first one, 1.2, it did do type coercion. Both the second one and the third one are both, second and third one are both not a number. So why did the third one become not a number and not 1 like I expected? Well, the reason for that is that unlike things like parse int, where it will read up all the characters up into the first non-numeric character because it's parsing your string, Math.floor takes the argument as a total. So as a total, even though it begins with 1.2, it basically says, there's some non-numeric characters in here, so I'm just going to kick it out. It's going to be not a number. So that's fine. So that's what happens when you do strings with Math.floor. Let's take a look at some other things. I've got some more code here. How about what happens with objects and other fun things? So I have an object here. I have the word undefined here, and I actually am passing a not a number variable, excuse me, not another data type into, or condition, I guess is the better word for it, into the Math.floor. What's going to happen with all 3 of these? Well, we need a number or something that can be type coerced into a number. So most likely all of these are going to come out to be not a number because you can't type coerce any of these. Let's flip back over to Node and clear the screen off. Type in node strange again. Yep, that's what happened for both an object for undefined and for not a number. It came out to be not a number. All right, we got a couple more to take a look at here. Let's flip back over to our code and let's now take a look at what Booleans, nulls, and an empty string does. And so these are Booleans and nulls and an empty string. We already know that a string that doesn't have a number in it is going to come out to be not a number. So I know the fourth one's going to be called not a number. Most likely number 2 and number 3, because they're not numbers or can be coerced into numbers, are also going to be not a number. And null, since it's definitely not a number, is also going to be not a number. So let's take a look at Node. Let's flip back over and let's clear up the screen and go to node strange and 1011. Okay, so what happened there? Well, again, we're taking a look at type coercion. So let's flip back over to our code. False actually can be type conversed into the number 0, and that's the way it is all the time. If you take a look at parse int, things like that, it will always come back to be number 0. True can be type coerced to the number 1, so we'll always return a number 1, basically not 0 in this case. Null is type coerced into a false, which is then type coerced into a 0. So that's why it came out to be 0. Now, I will admit something here. I would have actually also expected undefined to come out to do the same thing, because in a lot of different places, undefined is also coerced into false. So why undefined didn't return to 0, I don't know. So if you ever figure that part out, drop me a note in the comments for the video and tell me why null came out to be 0 while undefined came out to be not a number. And then finally, the empty string also is type coerced into a false, which is obviously type coerced into a 0, so that will return to 0. So that is why for the last 4 there we got 0, 1, 0, 0. So we flip back over to Node. As you can tell there, that's exactly what we got. 0, 1, 0, 0. So those are some of the strange things that can happen if you don't pass numbers into the Math.floor. How can you fix this? Do your type checking. Just pass numbers to Math.floor and you'll never go wrong. So again, that's all there really is to Math.floor. Remember, it returns the largest integer that is less than or equal to the number that you pass into it. And that's all there is to Math.floor. I hope you enjoyed our video. Hope it didn't bore you to death. Please view all of our videos at www.boringjavascript.com. Subscribe to our YouTube channel or check out everything we do at www.thevirtualvoid.com. Thanks again for watching, and we'll see you later.